Hey guys, welcome back to the channel. Today, we are exploring one of the boldest breakthroughs in the history of computing. That is, Google's claim of achieving quantum supremacy. Sounds very intense, right? But what does it really mean? Why did it send shock waves through the scientific community? And is it as historic as Google claimed, or was it just a hype? Stick around, we will break it all down today. Quantum supremacy refers to the moment when a quantum computer outperforms the most powerful classical supercomputer on a specific task. The term was coined by physicist John Preskill in 2012 not to signal dominance but to mark a clear boundary, the point where classical computing just can't keep up. It's a milestone, proof that quantum computers can do something definitively better, even if it's just one thing. Let's get to second one. In 2019, Google introduced the Sycamore processor, a 53-qubit quantum chip operating under extreme cryogenic conditions. As we have discussed earlier, these quantum chips and quantum computation requires a very low temperature that is nearly absolutely zero. These qubits were arranged in a two-dimensional grid, enabling efficient interaction between them. With extremely low error rates, over 99% fidelity, Sycamore was purpose-built to show off quantum speed. The chip itself was a part of massive infrastructure involving superconductors, precise microwave pulses, and ultra-low temperatures close to absolute zero. On October 23, 2019, Google announced it had performed a complex task called random circuit sampling in just 200 seconds. They claimed this task would take the world's most powerful classical supercomputer, IBM's Summit, around 10,000 years to complete. Now, this wasn't just a fluke. They verified their results using a technique called cross entropy benchmarking to ensure the output was quantum generator 1. The task? Random quantum circuit sampling. It sounds technical, and it is, but here is the essence. They created a pattern of quantum gates that resulted in a specific probability distribution of outputs. This pattern was so complex that classical computers simply couldn't keep up. There is no practical application to this exact task. It was chosen specifically because it was hard for classical computers and feasible for quantum ones, a test case to prove a point. To validate supremacy, Google's benchmarked Sycamore's result against Summit IBM's 200 petaflop supercomputer. Summit would take an estimated 10,000 years to simulate the task Sycamore completed in 200 seconds. That's the headline figure Google ran with. IBM responded, suggesting it might actually take a few days with an optimized algorithm. But even that's a massive quantum edge. The implications were huge. Overnight, Google's claim supercharged interest in quantum computing. Governments and companies began pouring billions into research. The event catalyzed development in quantum software, material science, quantum chemistry, and machine learning. Quantum computing, once seen as theoretical, now had proof it could outperform classical machines under the right conditions. Not everyone was convinced. IBM's challenge to the 10,000 year claim sparked heated debates. Many scientists pointed out the task had no direct real world application. Others even criticized Google for lack of transparency, saying their results were difficult to reproduce due to proprietary hard work. Still, Most agree this was a meaningful step, just not the final one. Since 2019, quantum research has exploded, but we are still in the early NISQ era. That stands for Noisy Intermediate Scale Quantum. I repeat it again. NISQ stands for Noisy Intermediate Scale Quantum. The real dream? Error corrected, scalable, fault tolerant quantum systems that can solve real problems like simulating molecules, cracking encryption, and optimizing logistics or financial models. We are not there yet, but the foundation has been laid. To wrap it up, Google's experiment wasn't the end game, but it was a milestone. Quantum supremacy showed that quantum advantage is not just theoretical, it's achievable. We are standing at the threshold of a new computing era. The next steps are even bigger, and you are witnessing history in the making. If you found this journey interesting, into the quantum world exciting, making sure leave it here. If you wish to subscribe, please subscribe. And what would you like to see quantum computer solves next? Let me know in the comment section. Bye bye, friends.